Hello. What you're seeing here is a continuation of the acid rain videos. You see a statue or decoration that's part of a building, but this particular part of the statue is all worn away. You can see that the detail of the face is all gone or smoothed out, right? Where when it was originally built, it was a very detailed face with all the facial features that you would imagine you would normally see, eyes, nose, and all that. What's happened to it is slowly over time, acid rain has started to deteriorate it. So even statues that were around for the last 2,000 years that have been that have held up pretty well are now being deteriorated by acid rain. And what's happening is the sulfuric acid that we talked about being produced and found in the rain is slowly eating away. So let's talk about the chemistry, the actual chemical formula of what's happening. All right, what we have here is the formula for the statue interacting with the acid rain. And in this formula, it starts off with the CO3, that's calcium carbonate. That's what the statue is made up of, is calcium carbonate. That's either limestone or marble. They both are composed of the same atoms, but they're different crystal sizes. But anyways, that calcium carbonate, which is a solid, that's why it has the S here, reacts with the sulfuric acid, the H2SO4. And then you see the AQ, which is just telling you that that's in liquid. AQ stands for aqueous, which just means liquid, okay? So that's the sulfuric acid that we find in the rainwater. Now the statue and the sulfuric acid react, and what ends up happening is that sulfuric acid causes a decomposition where you get calcium ions, and you'll notice that's aqueous, it's not solid anymore. You get sulfate, this SO4, which is also aqueous, so again, not solid. It's dissolved in the rainwater. And you get some extra water molecules and some carbon dioxide, this CO2. Now it's the calcium and parts of the sulfate and parts of the water and carbon dioxide, but really the calcium that is responsible for that deterioration of the statue. You can see little bits of the statue start to wear away. So this is the chemical reaction taking place. All right, in this image we have another statue. Now we've seen this before. This is a statue in Washington, D.C., and you see the degradation that's happened as the acid rain has slowly washed away bits of the statue. Remember, that was the calcium carbonate, the limestone, or in some cases, the marble. Usually limestone is what we're seeing. And it wears it away much faster than it would have if it was just the rainwater, where 500 years ago, the rainwater did not erode these statues. There's also another reaction going on here. I said at the end of the process, if you look at that reaction, we had calcium ions and we had sulfate ions. Now, if those don't get all washed away and they end up getting into the cracks, they form something called gypsum. And that's this dark material in the cracks. You can see all around that dark material kind of forming in the cracks because you get a second reaction taking place between the calcium, the statue, and the sulfate forming this gypsum. And this is a new crystal that gets in there, darkens the statue, but also opens up the cracks more than they would normally be. And you can see, especially in the face of George Washington here, large cracks have formed where we get that dark gypsum. All right, and then the last image here is just an extension of what we've been talking about. Besides statues, we do have buildings that in the past have been built using limestone. Limestone normally would be good for these buildings, but in this case now, if we do get acid rain or poor rain quality, air quality, it's going to start to slowly erode the buildings. Now, normally this is just the outside of the building. the decorative part of the building, it doesn't have an effect on the stability or structural integrity of the building. These are the outside facades where you would have the building that had detail and decoration to make it look a specific way. Um, and Primarily older buildings. The new modern buildings that you see, we aren't using limestone for most of these buildings.